To do is first of all take your blue sheet and discuss how you know it's a limosome, how you know where it's going to be, what these different things tell you, okay? And then about 2 minutes, we're going to officially write this down for our notes, okay? So talk about anything you can from the bottom half of your blue sheet.
All right,
Go.
looks like you got the answers. A circle-y looking thing. Hey, I got one right. Let's go. Did not keep that one right. It's not A, it's S. Yeah, that's not the sign, not like cosine.
Yeah.
Like negative or, yeah. But it's not A.
Okay, we're going to talk about this all up here together. Okay? Part 1, sine or cosine. What does that determine? Okay, good. So, direction. Also, yesterday we talked about the symmetry, right? We know that anything with a sine is going to have vertical symmetry. Anything with a cosine is going to have horizontal symmetry. Okay? Up here, these two equations, really, these 4 equations, those are how you're going to determine that it's a limosome. Okay? Our roses and our circles were A cosine n theta, A sine n theta. Well, now we have just theta, but we have a number plus sine, well, number plus a coefficient sine theta, a number minus coefficient sine theta. Okay? So it should stick out to you because there's going to be that addition or the subtraction. Okay? Pod 2. If we have addition versus subtraction, how does that affect our shape? Okay, so horizontally, is it going to be left or right? Vertically, is it going to be up or down? So if we have a positive, then it's going to be more positive, right? So is it going to be to the right or is it going to be up, right? Those would be where we have positive values. Negative, right? It's going to be either down or it's going to be left. Yes. Sure. Okay. Pod, did I ask? No. Pod 3, A plus B. What is that going to give us?
The size,
And what do you mean by the size?
how big it is.
How big it is from where?
Origin.
Okay. From the pole, A plus B is going to give us our size. You know how like in here, max R value, that's essentially what A plus B is giving us. How large it is from the pole in its biggest portion. Okay. Pod 6, I'm going to change it up a bit. Pod 6, what is A divided by B determine?
I said which type.
Which type? Okay. How many of you looked in your book at the 4 different types? Okay. How many of you noticed during our activity that when you played around with A and B, the shape changed. A couple people noticed that? I feel like more than a couple people noticed that, but, okay? Like one of them had a loop inside of it, right? And then some of you were commenting about how one kind of looked like a heart. And then one kind of looked like a misshaped circle, right? Okay? There's actually 4 different types of limacons. So we're going to go through what those 4 different types are. Okay? Now, depending on if it's sine or cosine, along with the addition versus subtraction, that's how we're going to know where a majority of our limacon is. So if you have A plus B cosine, a majority of it's going to be to the right. If you have A plus B sine theta, a majority of your limacon is going to be up. Okay? Now, for example purposes, all of these are A plus B cosine theta. So you can see the picture and everything. Okay? So, here are our 4 different types. What does that first one have that the others don't? A loop. Its name is a loop. So if I ask you for the type, you're going to write limacon loop. Okay? How do we know if there is a loop? A divided by B is less than 1. B is the number attached to sine or cosine. A is that number before the addition or subtraction. So if the ratio of A to B is less than 1, we're going to get that loop. Okay. Now, what does this one almost look like? It almost looks like a heart. And if you go to the doctor to look at your heart, you see what kind of doctor? A cardiologist. Oh wait, there's another I in there, isn't there? So there's 2 I's? Okay, I have a very hard time spelling this word. I don't know why. This happens when A over B equals 1, or A and B are the same, right? That's what that means. When A and B are the same, we get a nice heart. Okay, so yesterday we talked about making flowers. Today we're talking about making hearts. Right? We should have done all this before prom. You would have had nice promposals here. You never know. All right, now this guy. This guy kind of looks like the Pillsbury Doughboy's tummy, right? Like it has like the little. He's made of dough, right? It has like a little dimple, right? Dimple. Oh. Okay, if you have a dimple on your face, it kind of like concave in a little bit with that dimple, right? This is a dimple limacon. This is when A over B, we like to say is bigger than 1, but hey, there's a 4th option. Okay? So this is when A divided by B is between 1 and 2. Okay. And so last, what makes you mad?
They're not circles.
Oh, okay. So this one is like as close to the circle as we've gotten, right? But it's a little like flat, like it kind of looks like you rolled up some dough and you set it on the table and it kind of, when you make cookies, you roll it, you set it down, okay?
I just eat the cookie.
My husband actually gets mad at me when I bake the cookie dough.
Cookie dough is better.
I know. But it's actually not very good to eat. Both raw eggs and the flour. That's not good. I know. But a couple bites is okay.
As long as you don't do it a lot, that's good. You know?
Okay, so I will tell you something. These are the easiest to graph because we're going to plug in like the 5 easiest data values to plug in. What you need to be able to remember for tomorrow and then next Thursday, which type is it? Okay? Now, do all of these go through the poll? Okay? These two right here do not go through the poll. So will these two Lena songs have zeros? No. These will not have zeros. These will. Okay? So, also good news. I'm not going to make you find the zeros. You have to tell me the number of zeros, but I'm not going to make you find the zeros for a Lena song. Not always are they nice, and not always will we have them.
At least, like, those two that don't have zeros, they could just be an actual.
Oh man.
Why are you yelling?
No.
What are you saying?
No, because what's going to happen, I'll show you one. I'll show you when we get there one. Okay. All right. So guess what? We're going to do 4 examples. Okay, does that make sense? 4 examples for these 4 different types. Here's your first one. Write it down. R equals 2 plus 3 cosine theta. Hello, welcome. Okay, turn to your neighbor and tell them which type of limestone it is and how you know.
Do you start at limestone, but do you start at 0, 0? No, it's close. You don't start at
Kira, which type of limestone are we working with?
The loop.
We are working with a loop, and how do you know that it's a loop? All right, A over B would be 2/3, which we know is less than 1, so we have a loop. Okay? Our max R value. Think about what we talked about. Our max R value. And how do you get 5? Okay? We're going to take A plus B. 2 plus 3 is 5. Perfect. Okay? Zeros we always say for last. Okay? Like I said earlier, limasomes are the easiest to graph. Because guess what? You're going to plug in 0, pi over 2, pi, 3 pi over 2, and you're going to finish at 2 pi. Those are your significant points every single time for a limasome. You don't have to think about it. Okay? Those are going to give you the nice coordinates to plot. Those distances are going to be the easiest to graph. And then we'll figure out what our shape is. Okay? So, toughest part, figuring out which type it is, and then just doing some trigonometry. Okay? So 0, cosine of 0, 1. So we have 2 times 1, or excuse me, 3 times 1 plus 2 is 5. So at theta is 0, we're going to go out 5. At pi over 2, what is the cosine of pi over 2? 0. So we have 2 plus 3 times 0. So at pi over 2, we're going to move forward 2. At pi. What is the cosine of pi? Negative 1. So we have 2 plus 3 times negative 1. Okay. And this is why we get a loop. Okay. Since b is larger than a, when we get that negative 1, we get a negative number. So at pi, we have to move backwards 1. Okay. But at pi, we have to move backwards 1. Okay. The cosine of 3 pi over 2 is 0. So we get 2 plus 3 times 0. So at 3 pi over 2, we'll move forward 2. And then at 2 pi, we should get the same thing we got at 0. Okay, we end back here. Okay. Now, let's think about our shape. Okay. We know that since this is cosine, we're going to have horizontal symmetry. Since there was addition in between A and B, a majority of our graph is going to be to the right of the pole. Is that what is happening? Okay. So here we go. We got to figure out the number of zeros. Are you ready? We begin at 5, 0. Rotate to pi over 2. We know we have to make the loop. Okay. It should be nice and smooth all the way through, and that loop goes through the pole. The loop goes through the pole. How many times? Twice. So we have 2 zeros. If your loop is not going through the pole on tomorrow's quiz, you will not get full credit for your graph. Okay? Be careful. Don't get too much in a hurry that it's sloppy and it doesn't go through the pole even though you know it should. Okay? What do you guys think? Okay? Now, if I set this equal to 0, okay, to try to find the 0, we would cosine of theta equals negative 2/3. That's not a unit circle value, which is why I'm not going to ask you to find it, because I'm not allowing you to have calculators. So we could find the zeros, we're just not going to. That one's for you, Eli. Any questions on that one? Okay. Some of us are still getting kind of organized. I'm going to put our next one on the board. Go ahead and get organized. And as you're getting organized, I want you to discuss the shape in which, quote unquote, direction this limacon is going to be. Okay, so discuss the shape and direction.
It's Cardi B. It's going to go down. It's Cardi B facing Hey, kid, which way is Matt facing? For the max on the left, you add them together to the right side.
Hello, you ready?
Calculator or no calculator?
Yes.
Which one would you like? Calculator? Okay. Do you want me to just take it out in the hallway or in the math room?
I'll have you go in that
Okay.
copy room.
And then how long is this section? Like time-wise or?
Hold on, I grabbed the wrong one.
I'll just set a timer on my phone.
I'll set a timer.
Oh, okay, awesome.
So you can write on here.
Okay.
Just put your answers on here. It starts on the back.
Okay.
Okay.
Yeah.
Ready? Marissa, what type do we have? A what? Okay, so we have a limosome. That is a cardio. That, yeah? Did I get it right? Okay. And a majority of our graph is going to be where, Richard?
No, down.
And how do you know down?
Because it's sine and it's negative.
Okay, sine and we have subtraction. So a majority of our graph is going to be below the pole. All right? Like all limasomes, we'll plug in 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so help me out. Sine of 0 is 0. So we have 4 minus 4 times 0. Oh, I need to back up one moment. What is our max R value? It is 8. This is A minus B. B is still a positive number. Okay? So 4 and 4, our max R value is 8. How many tick marks do we have on this? We have like 5, don't we? Like these circles here, we have 5 of them. Okay, and if our max R value is 8, that's not going to fit, is it? I'm going to count by 2s.
Skip it.
Smarty pants.
Skip it.
Eli, you are having a negative effect on this.
No.
All right, pi over 2.
I'm teaching.
Pi over 2, what's the sign of pi over 2? Say louder. 1, so we have 4 minus 4 times 1. 0, so we are at the pole. Pi. Pi, Eli, redemption. What's the sign of pi?
0.
Okay, so we have 4 minus 4 times 0. Which is 4. So at pi, we're going to move out 4. Three pi over 2. The sign of 3 pi over 2 is negative 1. So we have 4 minus 4 times negative 1. There's our max value. 2, 4, 6, 8. And then you should always end up back to where you started. 0 and 2 pi should give you the exact same number, right? Because they're the same angle. Okay, so I'm going to draw a triangle. Do not draw a triangle. I know it looks like a triangle, don't draw a triangle. Okay, if you look back at the picture that we drew, that cardioid, it comes to like a corner at the pole. Okay, like you would draw a heart, it just doesn't have a corner at the other end. Okay, so when you draw this, you need to make, like when you would draw a heart, okay, a corner with those arches. But then here you would need to make this nice and smooth. You okay, Phil?
Yeah.
Okay. All right. Tiger, how many zeros do we have? We have 5 zeros. Okay.
Wow.
Let's try this, Tiger. This is where we began, right? This is where we started?
Yeah.
And then we drew this. How many times did we go through the pole? Okay, so are you thinking like when we touch it and then bounce back, that would be 2?
Or are you talking about like when we start?
So when we're talking about zeros, we're talking about where we hit the pole. So when we start here, we touch the pole how many times? Just once. So we're gonna have 1 0. Okay. Always the pole for zeros. Okay, always the pole. Okay. That's probably my favorite one. Well, I kind of like the loop too. Okay, we have 2 more examples to get through. Are there any questions before we move forward to our next limosome? Here's our next one. Write it down. Okay. Turn to each other. What kind of limosome is it? Which direction does it open? What is the max R value? Answer those 3 things.
I was just gonna open cosine. Negative. And it's not even this time.
All right, our limosome. Kiana, which type is it? Okay, and we know that because? Okay, so our A over B, 4 over 3 is between 1 and 2. Very good. Our max R value, Haley, what is that going to be? Okay, good. A plus B is 7. All right, and the direction of this dimpled limosome. Speaking where is the majority of this going to be? Up, down, left, or right? I like the horizontal because it's cosine. We have that negative right there. So we need it to be that negative. Okay? All right. I am going to give you a minute and a half to plug in your significant points and plot them, but do not draw your curve. Plug in the significant points and plot them, but do not draw it.
God, Caleb, you listen.
Our max R value is 7, so this would be another time I would count by 2s if I were you.
Check it out. Now it's got it plotted. Got it plotted. Oh, I forgot the episode.
Just gonna put it in the middle there. That's what it does.
I'm not drawing a curve. I didn't do it. Is this right? Check it out.
That's why.
That's why I said don't try.
I wanted to see if I could do it. I like to challenge myself. Oh, yeah, it's 0. Okay. Probably because.
Okay, everyone's gonna help me out here. The R value at 0. Okay, well, everyone needs to help me, not just 2 voices. R value at pi over 2.
4.
Pi.
7.
Ah, there it is. 3 pi over 2.
4.
And 2 pi.
1.
So if we're counting,
Oh, you went for the fixed voltage.
so 1, 4, 7, 4, 1. Why did I tell you not? Why did I tell you not to graph it? Okay? If we go back to here, there's a big difference between the cardioid and the dipole. Not only does one touch the pole and not the other one, but do you see how this one comes to a point? Does this one? No, it needs to be smooth. So when you draw this, you need to make sure that that indentation is smooth. Okay. Now, I realize that your graph isn't going to be perfect, but make it as smooth as you can. Okay? How many times did we go through the pool? Okay, so please write none. There are no zeros. I would prefer that you write none instead of the number 0. Okay, that way there's a distinct difference between the number of zeros and not having anything. Okay? Aren't these nice to graph? Like, we have nice points to plug in. We don't have to think too hard about where to begin, where to put a pedal, anything like that. Here's our last one. I just want to make sure we get the shape correct. Okay. Our last one, R equals 5 plus 2 cosine theta. Never knew you'd be doing so much gluing in math class, huh?
It's a convex.
Maverick, what type of limason do we have? Do you have the 4 written down somewhere? Convex. Might be a good idea to write those down after class. Okay, 5 divided by 2 is bigger than or equal to 2. So we have a convex limason. Max R length, or max R value. Lindsay A, what's our max R value? 7. Hey, another odd number for you. Okay, so I'm going to count by 2s again. All right? Okay, let's do these together. All right? Hopefully it's ingrained in your brain, the sines and cosines of all of these quadrantal angles here. The cosine of 0 is 1. So we have 5 plus 2 times 1. The cosine of pi over 2. 0. So we have 5 plus 2 times 0. The cosine of pi. -1. So we have 5 plus 2 times -1. At 3 pi over 2, the cosine is 0. So we have another 5. And then at 2 pi, we're back to where we started. So at 0, we have 7. At pi over 2, we have 5. At pi, we have 3. You notice how I labeled that I was counting by 2s? Please do that on yours if you decide to count by a number other than 1. Otherwise, I don't know what's going on, okay? I'm always going to assume 1 unless you label it otherwise. Now, our convex limacon, it's circle-ish, but it's kind of like flat here almost. Like to me, it kind of looks like a guitar pick a little bit. Okay. It's just a little squished over here. Okay. And since we don't go through the pole, there are no zeros. Okay, your homework assignment is the same length as last night. You have 6 graphs to complete for me here. I want to take a moment and talk about tomorrow's quiz.
That's good. We saved paper. Not bad.
Okay, can you use a calculator on tomorrow's quiz? No. This is what you need to be able to do. We'll work backwards. You need to be able to graph a limacon. You also need to be able to describe it to me. Like if I give you a graph or an equation, r equals 2 plus 2 sine theta. You need to be able to tell me that that is a cardioid limacon opening up max R value of 4. I can't remember. Okay. You need to be able to graph me a rose curve or describe it to me. You need to be able to graph me a circle or describe it to me. You need to be able to convert equations. You need to be able to convert coordinates. And you need to be able to plot the coordinates and describe them in a different way. So you remember how we talked about there's 4 different ways to write one coordinate? I am going to ask you to write a coordinate in a different way. Okay? Okay. So, like this is the coordinate, like this coordinate 5 pi over 2. I could write as -5 3 pi.
I don't know.
Because we could rotate to 3 pi over 2 and walk backwards 5. Okay.
Don't hold my eraser, Boston. Where is it?
For